Hello and welcome to Vitosh Academy with another live coding video. Today I'm going to speak about VBA loops and pretty much the basics about loops. So this is the content that I have prepared for today. Pretty much type of loops. We will go through for loop, do until, do while and while do. Then we will go through the basics, pretty much step 2, this is concerning for loop. Then reversed for loop and a nested loop. Then we'll take a look at the loops in Excel, pretty much looping through cells in a range and looping with offset. And at the end, just for less than 30 seconds, I'll try to show that loops are a bit more. For example, we can make really tough calculations and recursion and everything with them. So watch us, let's start. So currently in VBA, creating a new module and writing with the for loop, starting with the for loop, writing pretty much sub for loop, clicking enter, and the task would be to generate simply the numbers like this 1, 2, 3, 4, 5, 6, 7 and etc. up to 100. So this is the basic. So dim I as long. So this would be our counter, and then we'll say for I equal 1 to 100. Go to the next one. Whenever we don't write the step like this, the step is considered to be 1. So we can either omit it, like comment it out, or leave it. So in this case, let's say I'll leave it, although I never leave it when it is step 1. And here, the other thing is we should do the following. We should declare the worksheet. There are plenty of ways to declare a worksheet. In this case, if we don't declare the worksheet, it would go with the active one. But as far as I want to be a bit, let's say, more constant in my stuff, I would always declare the worksheet. So in this case, it would be worksheets Tabelle 1, because I'm with a German Excel. Or we can do worksheets index 1. Or what's the best thing to do is to go here, to change the name of the worksheet and simply say TBL main. For example, this would be the one that was going to be referred all the time, TBL main. And here we can say cells. Row index, you see, would be our I, and then 1, and it would be equals to I. Let's see what would happen. Okay, nothing happened. That's beautiful. Question is 1, why? Okay. That's rather interesting. And I would not stop the video to debug, because this shouldn't be the case. Okay, table main. Let's see what would happen here. Value A, and I don't see anything. Okay, you see it's with B, and if we go here, it is ready. Okay, that was a good one, like a joke. Yeah, so this is how it works. Further, we can go to debug print, and we can say I, just to see how the loop is working. I'm debugging currently with F8. And this is how it works. If we delete here, it would continue from the 5th. And yeah, this is pretty much the basics of the for loop. Going from 1 to 100 in this case, stepping with 1 and writing it here. Okay. What we can further do is, for example, we can take the square of I, so it should be 1, then 4, then 9, then 16, etc. up to square of 100, which is 1 with 4 zeros. Yeah, 1 with 4 zeros is, take a look, yeah, 10,000. Okay, so The rest I have prepared is this kind of a FizzBuzz game. I'm not sure whether you know it. It's a childish game, so to say. It's called FizzBuzz. And there the idea is that if let's say on every third number which is divisible by 3, you say fizz. For example, two kids are counting pretty much, and the one says 1, the next one says 2, then the next one should say fizz, because 3 is divisible by fizz, and then the next one should say 4. Then we go to 5, and because 5 is divisible by 5, we go buzz. Then we go 6, 7, 8, no, we go 6, but 6 is divisible by 3, we go fizz. And in 9 we go fizz again. I'm just guessing here, yes. And at 10 we say buzz. So that's the idea. And if the number is divisible by both 3 and 5, we write FizzBuzz like this. So let's try to translate it. For loop FizzBuzz. It's a really old game, so this will be the thing that we are going to write, and we're going to write it for the first 100. So the value would be the result, and we will be printing also the result, and we'll be printing also I. Yes, like this. Now, how do we declare the result? Well, we need an if. So if I mod 3 equals 0, then in here end if. Okay. Else if I mod 5 equals 0, then else if I mod 3 equals 0 and I mod 5 equals 0, then else. Okay, the else here would be our result, which is none of these three cases, so result equals I. Okay, let's see what would happen here. If I mod 3 equals 0, result would be pretty much fizz. If I mod 5 equals 0, the result would be buzz. And here the result would be FizzBuzz. If anyone is watching, I know there is some kind of something here, but I'll explain it later, just to make sure I'm on the right one. Here I would say show what exactly mod is. For example, mod is the following. Let's say 7 mod 3 is 1. What does it mean? It means that 7 can go into 3 can go into 7, let's say 2 times, and there is like 1 left. So 15 mod 5 should be 0, because 5 goes into 15 exactly 3 times and there is nothing left. But if we try 16 mod 5, it should be 1. Okay, let's run it and see what's going to happen. Okay, we see fizz, buzz, fizz, fizz, buzz, fizz, and a problem. Also, we have it here in the direct place. For example, I'm going to add something like VB tab here, and then this. And then run it again. Most probably the tab should have been here, just making it a bit more beautiful. Yeah. And why didn't we start with 1? We didn't start with 1 because, let's see, stop. Okay. Okay, I probably didn't scroll up to all the way. Okay, so the problem is that it works kind of okay, but it's not okay, because we see at 15 we do not get FizzBuzz. with only get fizz. Why is this the question? Because it is if, else, if, else, if, else, if, else, and it probably never enters here. Because in order to enter here, it should have entered before, either before here, and this is an else if. So let's see, for example, put a stop just to make sure that it doesn't enter. And yeah, indeed, it does not enter. So what should we do? Well, in this case, we should switch a bit the conditions. This one should be added here. So the first one is whether it's FizzBuzz at all check. And if it is FizzBuzz, then we write FizzBuzz and then we escape. Otherwise, we check for buzz. Otherwise, we check for fizz. Let's run it. And yeah, so the kids that are playing start 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 4, and FizzBuzz. Okay, so really, I don't know, strange game, but probably if you don't have anything better to do, it's an interesting one. If you're like, I don't know, not 5 years old, but let's say, I don't know, 10, for example, if you play it really quickly, yeah, and you start from 1000, for example. So this is so for the for loops. The next one is the do until loop. Okay, so pretty much what the do until loop does. Let's see. Do until. I'm going to delete also this one with the FizzBuzz. The do until loops, just declaring I as long, pretty much always says do and then loop until true. It would do it at least once. It would go through the condition until the condition here is true. So it would be like 1 equals 1, which is eternal truth. Simply write here true. So what our condition would be, table main sells, let's say 1, 1 equals I plus 5. And we can going to start like this. And we only looped once because the condition was already true. You can also put a debug print I plus 5, and it would only show it once. So what can we do with this one actually? We can do a lot of interesting stuff. We can loop through all the way down. Let's see. Let's write the following. Let's say write in the first column, which would going to be I, and declare if I equals 1 in order not to get a mistake. And simply say I equals I plus 5 and loop until false. Yeah, let's see what is going to happen here if we say loop until false. I am expecting that it should go all the way up to the 1 million row, and then there would be an error. Why is the error happening? Well, because I is 1 million something, which is obviously more than the rows in Excel. What should we do? We can say loop before loop until I is less or equal than table main rows. And the last thing to do is to write I. Let's say once the thing is over. In order to end the thing, I'm going to write end in the direct window, or in Deutsch Bereich, whatever this is. Yeah. Okay, nicht genügend Speicher. Okay, let's see. Okay, this is something that shouldn't be happening because table main rows. Table main rows count was what I had to write, of course. Okay. Okay, it's less than. Okay, so it's only looped once. but now it should be looping more, because I also made a mistake there. Yes, so going all the way to the 1 million something, all the rows in Excel, and this is it. 1,048,000 something. 1,048,576. Yeah, but we have the I plus 5, so that is it. Yeah. So this is about the do until. The important take-home message with do until is that it actually loops at least once. In order to make the condition and to make sure that the loop enters, the code enters the loop here on a condition, we can use do while. Okay, do while, and we simply say do while true. Pretty much the same. And let's see. It would go again into an error. Of course. But with do while we have one bonus. We can say if I less more than table main rows count, then exit do. And this is the beautiful part. Now there shouldn't be a mistake in our code. This exit do actually is a great thing. It exits the whole loop. Yeah. So this is what I have prepared with do while. The next one is actually one of my favorites, because this is how you program games. I mean, on a really basic way of programming, it is working with while loop only. So it is like this. Declaring a counter, then saying okay, counter is equaling to I, and then we say while true vent, and while true table main cells I1 equals simply I, and here we increment it I plus 1. Now the beautiful part is that it's going to get an error, and let's see what would happen. I'm just pressing F5, so it should go once again to the 1,000,000th for 48,576th row, and it should get an error. Okay, my computer is a bit slow here, but this happens. Okay, so finally I got the error. Let's see debug, the same thing. What can we do here? We can say, hey, I want to see the error, actually, error description, and this is it. In German, but we get a lot of other stuff. Error number 1004. This is one of the basic error numbers in VBA. What can we do here is pretty much say while I equal or less than rows count, and specify table main, of course, and see whether it would enter at all the loop. It shouldn't be entering the loop. If we only take the loop condition here and evaluate it in the direct window, it should say false, which is falsch in German, but whatever, I don't have English Windows, English Excel here. So it wouldn't enter the loop, long story short, and it would exit. So that's the beautiful part of the while only loop. So following our point, the next one was working with steps. So for loop step, I'm just going to delete this one, and let's say dim I as long, and here we can say for I equals 1 to 100, next. Let's imagine that we only want to write the FizzBuzz in this case, or pretty much the buzzwords, step 5. Yeah, the buzz and the FizzBuzz. So if I divided by 3 equals 0, then it's not like this, it's mod, then else, and if I'm going to say result equals, okay, about step would be buzz, and the result will be here. And if it is both, because we're going through step 5, it's going to be buzz by default, and if it is divisible by 3 as well, it will be FizzBuzz. Let's see how it would work like. Table main cells I column 1, or we can nicely do something like this fashion, and we can write value just to save some really tiny milliseconds, which I usually don't do. And here we can write result. Okay, the word result is not defined because we have option explicit. We write dim result as string, and let's see what happened. Yeah, you see. Okay, it didn't work the way I expected it, honestly. Why? Because 1 plus 5 is not the way it should be. Okay, let's think. If we start with, okay, this way, that's a really tricky answer. If we start with 0, then 0 mod 3, but the first one would be a mistake. I have to think a bit here how to write it, but before this I'm going to show what exactly happened with this step 5. It always goes like this. Okay, so the first one should be actually step 4, and then it should be step 5. In order to make it work, it should be like, it's really bad code, this one. Shouldn't be writing like this FizzBuzz, because this is not the correct way. Okay, I found the correct way to write it only with buzz and FizzBuzz. It's like this. Starting from 5 to 100 and step 5. So this is how it works. And we see that currently I is 5 once we run it, and the next time it is 10 because of the step. So yeah, it works. It works okay. And the next one that we're going to show is the reversed loop, the reversed for loop. So we name this for loop. Dim I as long we're going to leave, and what we're going to write here is pretty much for I equaling 100 to 1 step 5 or step 3, and we're going only to say table main cells I1 equals I. Just deleting all this FizzBuzz stuff. And let's start with F8 debugging. And we did not even enter the loop. The question is why we did not enter the loop. The answer is because I equaling 100 to 1 step 3. The next one would be 103. And as far as 103 is bigger than 1, it wouldn't even enter. So we have to make it negative. So with reversed loop, we always do it negative step. So let's try. Okay, there should be something in here 100, 97, 94, 91, and this is how it works up to the end. Pressing F5 here. Oh. And what can we do? Let's demonstrate another reversed for loop. Pretty much from 10 to 1, step -1. Yeah, it works like this. But the tricky part is that we first filled up this one. Take a look. Yeah, that's pretty much the reversed for loop. Continuing with the nested loop. Okay. Deleting here and writing nested loop or nested loops. Okay, so what's a nested loop? Well, that's rather complicated one if you're first time working with loops and this is your first loop video, trying to pretty much to say what I'm doing here. I will declare rows and columns as variables. And what I'm going to do is I'm going to write values in all the rows and all the columns. Let's say for my row, equaling 1 to 20, for my column equaling 1 to 10. Next my column, next my row. Here we don't have step 1, but it doesn't bother if we write it. And here what we do is then with worksheets or with table main and here we can write dot cells, my row for the row, my column for the column, equals pretty much cells, my row, my call dot address. Let's see, simply like this, what would happen? We get the address property of the cell for each one of those. What exactly did we do? Let's stop. Let's delete. Should buy probably a faster PC because this one is, I'm even hearing it, but let's wait a bit. So starting with F8, it says, okay, my row is 1, my column is 0. My row column is also 1 now. We can add it to the watch. In German it's Überwachung, but hopefully you're using the one in English, so it's a watch window. And we see here, so with F8, so my column is now 2, this will be this one, my row is still 1, so we are still within this loop. You see, we only go into the inner loop, and we would go in the inner loop so many times up to the moment we exit the loop. Okay, now we should exit the loop, yes. And now my row is 2, so we would try to enter this loop again, and we would be looping up to the moment until we don't have to exit the loop, and then we simply would do it again and again and again until this condition for the loop is finished. So this is it. We started here. This is the first running of this loop, then for the second running of this loop, and these are, and we know that we have to run it 20 times because this is the condition here, 20, 1 to 20. We write 1 to 5, we would run it 5 times here, so like this. And yeah, just to give you some idea what can we do with this kind of nested loops. We can do plenty of beautiful stuff, not only the address, but we can say, hey, I want to see how much is my row number times my column number. And this is it. 5 times 1, 2, 3, 4, 5. So the column is 1 and the row is 1. It's 1, and we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5 it's 40, or 8 times 1 is 1. Yeah, we can do plenty of interesting stuff once something needs to be done in production. So pretty much that's all for the nested loops. Continuing with the loop through cells in a range. Sub loop through cells. Okay, so the cells in a range are part of a collection. Pretty much we can do the following. We need to define them, so it should be dim my range is range, and in this specific time I would use the word selection, which is not a good idea to be used, but only using it for demonstration purposes. Don't use it in code ever. The my cell is range. So for each my cell in my range, next, and we'll say my cell.value equals my cell.address. Running it with F5, and this is it. Magic. My cell value is equals my cell, let's say, row plus 100. Yeah, simply loops. Or we can say my cell equals E, and we can say dim ES long, and here say E equals 1. It's all ones, but if we want to see what's happening actually, we can say also E equals E plus 1. So we can see which is the first one being filled out. And this is it, how it fills out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 100 will be pretty much interesting also. And yeah, if we don't want to use the word selection, which is a great idea not using it, we can say table main range A1 F20, run it, and it works differently. Run it again, and it also works the way we would like to see it. So that's the idea. Like, all the cells in a range are really part of the collection. Like, the range is an object in VBA, and as such an object, it has plenty of properties, and as well it is a collection of cells. So there is something called, we can iterate through it and see how stuff are done here. So next one would be working with offset. Look through cells, offset. Here with offset there is something important, just to explain what exactly an offset is. Let's imagine that we have this selection and we say 100 should be the value of this selection. Great. So what would happen if we say selection.offset 55 equals 21? Quite okay, but probably no one understood what's happening, and it would take quite some time to explain it. So let's try with selection of one range. So 100 and 55 equals 21. So it is, offset means like 1, 2, 3, 4, 5 going to the right columns, and 1, 2, 3, 4, 5 going to the down, and then 21. If we say selection offset -1 equals 1, then it should give us this one here. Yes, this is what it does. So that's the idea of the selection of the offset. It can be also -1. So for the negative we go up, for the negative rows we go up, for the negative columns we go left, and for the positive we go right, and for the positive rows we go down. What would happen if we say -100 here, or -10? Well, of course, we get our beloved error because -10 is not present in Excel. So let's write some example. Yeah, what should be the example? For each my cell in my range, let's say my value would be 2, and my cell offset, my cell row, my cell column would be 1. Let's see what would happen. This is what happened. This is the initial one with the 2, and with the offsets we get these ones here. So yeah, we can do some stuff with the offset depending on whether you really need it, but it's a beautiful one thing. So at the end, I was talking about going to a bit more advanced stuff in VBA, and the advanced stuff was working with displaying all combinations from VBA from a given array. I mean, I wrote yesterday an article about it, so today I decided to make a video. This is pretty much what is it working. I'm simply going here and I'm going to copy the code and then explain what is happening. It's a really, honestly tough code if this is the first time you're seeing loops, but just to show you that life is really not as easy as probably someone may think, especially in programming. So what are we going to try here? We have this array of numbers 1, 2, 3, 4, 5, 6, and in this array we are going to write all combinations that are consistent of 4 elements. So pretty much we will start we will start with 1, 2, 3, 4. Then we say 1, 2, 3, 5. Then we say 1, 2, 3, 6. And then we would continue with 2, 3, 4, 5. And so on. 2, 3, 4, 6. We would not enter, let's say, 1, 2, 2, 5, because this is not a combination as 2s are repeatable. And we would not continue with 1, 3, 2, 4, because this is the same as 1, 2, 3, 4. I mean, just the order is different, but these are combinations and not permutations. Furthermore, as you see, probably this could be done with loops, but if we do it with loops, it should be we should add a new loop every time we change the size. And here with the size, we are pretty flexible. For example, we can add also in the array here, and let's see what would happen now. Yeah, 1, 2, 3, because the size is 3, 1, 2, 4, 1, 2, 5, 1, 2, 6, 1, 2, 7, and then it starts. And pretty much these are all of them. 5, 6, 7 is the only one starting with 5. We can also say, okay, let's see the size of 5 in this case. There should be really not a lot. Yeah, and the size of 6 actually should be exactly, if I'm correct, they should be exactly 7. Yes. 1, 2, 3, 4, 5, 6, 7. Yes. 1 without 6, 1 without 7, 1 without 6, 1 without 5, and so on and so on and so on. So pretty much that's all for today. Thank you for watching and enjoy your day. Have a great day.